Hello everyone and welcome to our fourth webinar in the series. This one is on ventilation and I'm really delighted to have our expert speaker Marianne Heaslip from People Powered Retrofit. So for the first couple of minutes I will be doing the introductions and a little bit about CAFs for those who haven't come across us before. Then I'll hand over to Marianne who'll speak for about 40 minutes or so on the subject of ventilation primarily, and then do save up your questions for the Q&A, and we'll have about up to 30 minutes for questions, and then we'll have a wrap up for the final 10 minutes and close at 8:30. So if you're not already aware of CAFs and what we do take a look at the website. We do lots of different projects. I don't want to go through them in detail now because it's quite repetitive, people who've listened to this webinar or this series before. Also, just a quick plug for our gift cards in our shop. There's 4 different gift cards, so do have a look if you're thinking that might be something you'd like to look at for giving for Christmas. I'll start off with a bit about CAF's energy services. It splits into 2 really. We have the free services, Cold to Cozy Homes. We run courses and webinars like this one, which are often funded by people like Energy Redress, who are funding this webinar. And we have our paid services as well, which start with a free retrofit phone call and a quote. And then we've got our paid for service, which starts with Home Retrofit Planner. And we have other follow-up services that we're now developing through a pilot. So for those who haven't come across Cold to Cozy Homes, do go on the CAF's website. It covers all the basic common sense stuff, but it also talks now about retrofit, government funded measures, and how you might be able to access those. So it depends sometimes on eligibility. Do take a look at the Cold to Cozy Homes website. Many people will be eligible either because they're of retirement age or small children or health conditions or low income, so a whole range of different things. For those who are looking for an in-depth whole house energy audit and looking to pay for that, then that's what we do using Home Retrofit Planner, which is an energy model, and it looks at the baseline of your home and then looks at different scenarios. And that's a very in-depth piece of work with a report, and we then offer follow-up services which are now in a pilot stage. For those of you who have been to one of our events during October or November, you'll have come across our Retrofit Made Easy project, and we'll be doing more of those events in January and February. In those communities where we're doing these events, we've got volunteers doing thermal camera surveys for free for householders. And if you're lucky enough to be in one of those areas listed on this slide, you could also get a thermal survey by a volunteer if they've got the capacity. So dig on the CAF's website, we'll have the link on the follow-up email, and that's something you might be able to benefit from. We've also got our Solar Made Easy programme, where anyone in Cumbria can get some independent advice and quotes from local vetted installers through our scheme. So that's been running for quite a while. There's information on the website again. Do just take a look if that might be something you'd be interested in. And what I'll go on to next then, introducing Marianne. So Marianne is now the technical director at People Powered Retrofit and has, I think, more than a decade working on retrofit projects and also developing the tools to support retrofit. So the Home Retrofit Planner that I just mentioned, that's a software tool that has been developed by People Powered Retrofit, and Marianne has played a huge part in shaping that piece of software. Much of the work has been developed alongside Carbon Co-op and other related projects. And she's also worked on projects and processes to scale up retrofit, so social housing and for community organisations, not just individual homes, and through some of those well-known government projects there that people may have come across if they've been following retrofit cutting-edge developments or showcase projects from the beginning. So I'm going to hand over now to you, Marianne, and let you share your screen.
Okay, thank you, Tina. Right, I will share my screen in a moment. Apologies for the slightly bare background. I just moved house this week, so I'm still finding my way around things. in the new setup. Can everyone see that? Can you see that, Tina?
Yes, that's great. That's showing clearly.
Perfect. Thank you. Right, so yeah, as Tina says, I've worked on retrofit for quite a long time now. I come from a background of being an architect and originally a project architect working on things, but also getting involved in policy and tools. I think ventilation is something that is incredibly important and often overlooked, with sometimes disastrous consequences. So hopefully you will all get something from this and learn about how important it is and also some of the principles behind it, and behind how you think about getting it right, really. Let's see if I can shift on the slide. Oh, there we go. So we do have an optional break in this. We'll see how we go. We might just plow straight through, given the format tonight. We've had our introductions. I will do a very brief recap talking about the whole house approach. So that's thinking of the house as a system. The first half of the bulk of the presentation and talk is really about why ventilation is important and what it is. And then that's followed up with some information about standards and regulations, different types of ventilation system, and a few pointers for things you could do immediately to improve the situation in your home hopefully without too much effort. So we're not going to be going into lots of technical detail about specific products or systems, but we are going to be talking about the principles, why it's important, in the hopes that then when it comes to talking about the products and systems, you've got that background understanding, which means you can ask useful questions of people who are kind of looking to install ventilation or sell you a ventilation system, or if you go to visit someone's home and see their ventilation system set up. So we've done that bit. I'm from People Powered Retrofit. We're another community energy organisation based in Manchester, a community benefit society. Do a lot of work with CAFs, have an awful lot of respect for CAFs and what they do. So it's great to be invited to do this evening. A whole house approach, right? I will fly through these because if those of you who've been on the previous webinars will have seen some of this, but I think it's important to always bear in mind that houses are systems. When we're talking about the whole house approach to retrofit, we're not actually necessarily talking about doing a whole house all at once, doing all the measures, all the insulation, all the air tightness it possibly could to that house then. We're talking about treating the house as a series of interlinked systems that they all interact with each other, they all affect each other, and we need to understand really what the existing context is and how that might change if we're going to start retrofitting homes successfully. So yeah, the one that everyone kind of thinks about really is the fabric heat loss. So that's the heat that's lost through the walls and the floor and the roof. But ventilation is a really key part of that as well, both because that affects indoor air quality and it affects heat losses. And then you have your heating system on top of that. So that's interacting with the ventilation system and your fabric heat losses. Hopefully, in an ideal world, your heating system is topping up for the losses. And then you've got lighting and appliances. How efficient they are can affect how much heat you need. And then there's also people and how people behave and what people do and how many people live in a house at what kind of density and how they dry their laundry and all those kind of things can really affect indoor air quality and type and how successfully your ventilation system operates. So understanding all of those things is really important. I think we're also, in recognizing that a house is a complex system, you're trying to understand the specific context of each house, and every house will be slightly different. We take a risk management approach to retrofit, which is about understanding that context, understanding the hazards that might be involved, the risks, and what you might sensibly do to mitigate those risks whilst improving the situation, being aware of unintended consequences. The biggest of which, really, I guess, when we're talking about ventilation, is if you install lots of air tightness, draft proofing work, you do a lot of insulation work, you make the home more airtight. If you don't think about ventilation, then the risk is you trap moisture and pollutants inside the home and you make it quite an unpleasant place to live. And one of the things to note, especially about ventilation and how buildings operate, is that over time, the way that we ventilate buildings has changed. And we've got quite a large proportion of the housing stock in England is much older. There's a lot of stuff from pre-1919 and also mid-20th century. I think that's especially true in Cumbria, actually, as well. The big difference, really, is that in older homes, people had coal fires, they had gappy, leaky windows, they had open floorboards. The coal fire would be lit and it would continuously draw air through the building. So you'd get a very high air change rate. And that also affected how moisture moved around the building. The way that modern buildings work is really that they tend to be more sealed, so less permeable, less open to air, with planned mechanical ventilation, so extract fans or sometimes whole house ventilation systems, and a lot of draft proofing and sealing. I mean, how successful some of that draft proofing and sealing and things like, window seals, open to question. And I guess the other thing to say here is that whilst this diagram, which is from English Heritage, we're now Historic England, actually, document that's quite useful, while it presents this dichotomy, in reality, a lot of the buildings that we have today are some kind of mix of both of these approaches, and are going to vary a little depending on what's been done to the building over time. And where it is and what materials it's made out of. So, why are we bothered about indoor air quality? So the biggest reason is because it affects our health, because we spend so much of our time indoors. And indoor pollution can be, and by pollution I mean anything that's moisture, too much moisture, different pollutants. If you have too much of that in a building and you're in there all the time, that's going to pose a risk to your health. And unfortunately, we've seen that illustrated quite dramatically and tragically recently with cases of mold in homes where indoor air quality is affected, really badly affected people's health and caused very serious problems. So, what causes indoor air pollution? Because it's not like the stuff from outside, although some of the air from outside obviously gets into our buildings. So that is a factor if you live by a busy road. So I think these slides are slightly out of order, but yeah. So the symptoms, if indoor air quality is affecting your health, it's likely to be exacerbating things like asthma, allergies, especially respiratory problems. Sometimes if the air is bad, you can get headaches and nausea, shortness of breath. You've also, it's not necessarily just physical effects that it can have. Occasionally it can start to have more mental health effects, and there are studies which link poor indoor air quality to higher incidence of depression, for example. So there's lots of things that we'd really rather avoid. The biggest one of these, really, and I suppose the most common that's talked about and that is also completely unavoidable because we're 70% water, is water vapor. And managing water vapor is one of the biggest things that can affect how you manage water vapor, is one of the biggest things that can affect your indoor air quality. we just produce it all the time by cooking and doing the laundry and showering, bathing, and by breathing. So completely unavoidable. There's a very good video on the link here that I would recommend you watching. It's from the UK Centre for Moisture in Buildings. It's just a little animation of kind of the causes and the consequences of moisture in buildings. Obviously, you can still change your behaviour a bit. So when people talk about the importance of laundry drying habits and whether you dry your clothes indoors or outdoors and how you dry them indoors can have a big impact. But there are obviously limits. Beyond that, where you are has a big impact. So in damp places like Cumbria, and I grew up in Workington, so I know exactly how damp it can be. Managing moisture really isn't easy. Relative humidity is high for a lot of the year. There's a lot of rain about, humidity is high. If you also then happen to live near a river or a beck, or somewhere where there's high water table, that can increase the moisture load in your home because there's water coming up from the ground as well. So in that context, what you really need to manage moisture is ventilation. Some of you, given the knowledge of the audience, may already be aware of this, but it's worth repeating. Ideally, for the benefit of everyone's health, internal relative humidity should be between about 40% and 65%. So that's what the little chart there, which comes from an ASHRAE publication, which is the US Services Engineers Professional Organization. That just shows that in that optimum zone in the middle there is where you have the least incidence of things that we're wanting to try and avoid, like viruses or mold and fungi and dust mites and things. Above 60-65%, and the air is generally too damp, and it might lead to an increase in some of those things. Below 40% is where, if you ever experience it, probably especially in weather like we're having at the moment, where the outside air is very cold and therefore also likely to not have very much moisture in it, which we'll go into in a bit more detail later. That air comes into your house, is warmed up, but it's quite dry. So you start to experience irritation, you kind of get a bit of a cough, or your eyes feel a bit itchy. I think on that, understanding what relative humidity is can be incredibly useful. And essentially, it is relative. So it's about how saturated the air is, how close it is to reaching its maximum holding capacity. That is the amount of water vapor that can sit in the air without condensing and becoming rain, basically, or condensation on walls, that kind of thing. So when relative humidity is 100%, the air is saturated, which means it's reached the dew point, so the point at which dew will form. So any more water added to the air will condense and become liquid. So it might be condensation, fog. If you're outside, hopefully you're not getting fog in your own house, or condensation on a window pane. There's a little tool here which is quite helpful to have a play around with yourselves to get your head around this and see what the relationship is between temperature and relative humidity and the dew point. It's just a little dew point calculator. The other thing to note is, because of this relationship, well, because of the properties of air and moisture, water, warm air can hold a lot more water vapor than cold air can. So the holding capacity, basically, of air increases the warmer it gets. The same amount of water vapor in the air at 100% relative humidity at 10 degrees Celsius will actually only be about 28% relative humidity once the air is warmed up to 30 degrees Celsius. So this is useful to understand, I think, when you're thinking about if you're looking at how successful your ventilation strategy has been in your home and you're monitoring the humidity, to understand these relationships and what you can do to help manage it. So the opposite is also true. So if the air cools, then it holds less water. So This is why you end up with condensation on cold surfaces. So if you have a window that's maybe only older double glazing or single glazing, or even on a day like today when it's almost sub-zero outside, even quite good double glazing, that window pane will be colder. Generally, the surface of that window will be colder than the air inside the room. So the air is moving around the room, it's holding water vapor, but as soon as it hits that window pane, which is much colder, doesn't have the carrying capacity that it had before, so the water condenses out of the air and forms condensation on the window. There's a direct inverse relationship between relative humidity and temperature. So there's just lots of ways of saying the same thing here, I'm afraid, but it is quite, once you get your head around the concept, it's really useful, but sometimes it's a little bit counterintuitive. So yeah, as temperature goes up, relative humidity goes down, assuming the amount of water vapor in the air stays the same, and vice versa. I suppose the important parameter to note when we're talking about retrofit, and one of the reasons why retrofit is beneficial, and I would say including retrofit that raises the surface temperature of the walls around you and the room around you, and raises the air temperature within the building, is because if your home is often quite cold, so say your average temperature in your home is between 14 and 18 degrees C, especially in a climate like we get in the northwest of England, it's very likely that even on coldish winter days, the relative humidity will be 70% or higher for a lot of the time. So that's when you start to get issues. The simplest way to tackle that, though not necessarily the most affordable way, is to turn up your heating. Not possible for everyone, not something that can necessarily be done. The other thing that you can do is ventilate, obviously, but yeah, throughout the year, external relative humidity and absolute humidity change with the climate. So the amount of water vapor in the air and the carrying capacity of the air change over time during the year. In summer, generally, relative humidity is a little bit lower. So in winter, it might be more like 100%. In summer, it might be more like 60, 70%. The absolute humidity in summer will actually be higher because the carrying capacity of the air is that much higher. But because the temperatures are higher and the carrying capacity is higher, it's less likely that the air will reach dew point and saturation point. So that's why fogs and mists and things tend to happen in the autumn and the winter, not generally in the summer. And that's, yeah, just what I've said. And the the point to note, and this is very true on days like today, as I said, you're bringing cold air from outside into your home, say it's 0 or 5 degrees C outside, you're bringing it into your home and heating it up to 18 to 20 degrees C, that air will have the same amount of water in it, but the relative humidity will drop quite a lot. The practical implication of this, and the useful thing, and this is where ventilation really comes into its own, I guess, and supports, is that means that in the middle of winter, if you've got a problem with, if you've got excess moisture in your home, in the atmosphere in your home, if you simply ventilate properly, so you're bringing in some of that colder but drier air from outside into your home, replacing that moist air in your home, that should help you manage levels of humidity in your home and then deal with a lot of those things that we were talking about before that you want to avoid, like mold, like dust mites, keeping your home within that kind of 40 to 60-ish% relative humidity target. In winter, that's relatively simple to do. In spring, summer, and autumn, it gets a bit harder because the temperature difference between inside and outside is less. And so you can't use that same neat trick, really. Although it does still help, and especially, especially on colder days. And it obviously, as we'll talk about in a moment, there are lots of other reasons to ventilate. But I suppose the reason for mentioning this is that if you notice that the relative humidity in your home is a little bit higher in the middle of summer, I would worry less about it. The thing to note about humidity is that whilst temperature is something that we're very, very sensitive to, humidity we're less sensitive to. Sometimes you'll notice it because it's so dry that your eyes get itchy. Sometimes we'll say, oh, a room feels stuffy because it's very high humidity, but generally we're not very good at sensing it. We would always recommend that people, as just a first step, get a hygrometer, start to monitor the temperature and humidity in your home so you understand how it's behaving and you can start to manage it more. When it comes to managing moisture, I know especially in somewhere like Cumbria, there's a lot of traditional buildings where internal lime plasters and things would have originally been used, and they can be helpful in kind of modifying internal environments, but they're not the only reason. Like, they're not going to be sufficient to make sure that your home is healthy, because there are lots of other reasons other than moisture why you would want to ventilate, other pollutants, which I'll just quickly run through now. The biggest and most important of these, and something to be aware of if you've got any kind of fuel burning appliance in your living spaces, is carbon monoxide and PM 2.5. So PM 2.5 are the small particles you get from burning, basically burning anything, but especially if you're burning wood, that kind of thing. They're quite bad for us. They can aggravate asthma and other conditions. There's also recent evidence that they can contribute to development of things like Alzheimer's. So really, if you have a wood log burner in your house, you definitely need to make sure it's properly ventilated and it's got a decent air supply. You can fit direct supplies to them, which can help. The other thing I would say is please, please, please fit a carbon monoxide monitor if you don't have one already, and even better an alarm, because that's a killer. So we definitely want to avoid that. Radon is the other thing, which is a factor in parts of Cumbria, as you can see from this map. The reddish bits are where we've got higher risk of radon. It's a radioactive gas, essentially, that just comes from the ground, depending on the rock formations below it. So you need to make sure that your ground floor is sealed, that the radon is ventilated away. Ventilating the inside of your house can help with this as well, minimize the risks. And then there's just carbon dioxide. So that's just what we breathe out a lot of the time, or that comes from combustion from fuel burning appliances. It really needs to be removed and kept below about 1,000 parts per million at least. Above that level, you'll probably start to feel a bit sleepy and a bit groggy. Won't necessarily do you serious lasting harm, but it's not good for you. And then there's lots of other potential sources of indoor pollution. So there's just general smells and odors from cooking, or from, other activities. Off-gassing, volatile organic compounds from floor coverings or furniture, especially different types of plastics. Things from cleaning chemicals. You don't want any of this hanging about in your home. And the best way to get rid of it is to ventilate. Although actually, if you can, say with something like VOCs, volatile organic compounds, if you're able to avoid introducing them to your home in the first place by using, for example, low VOC paints or other finishes, then that's a good idea too. But once they're in there, you need a good planned ventilation system to get rid of them. And yeah, smells and odors, which aren't necessarily dangerous, but you don't necessarily want them hanging around. So just before we go on to the next section, I wanted to check and ask if people can put something in the chat, just to check out if I've explained it well enough. Are people comfortable with the idea of what the difference is between relative humidity and absolute humidity. And I don't know, Tina, if you can see the chat.
Yes, I've got it open now. So if anyone could just put a very short, or a couple of people can put a very short summary of the difference between relative and absolute humidity, that would be brilliant. You should be able to type in the chat. Yes, I've got relative changes with temperature.
Yeah.
And that's the one person who's been brave enough to say something.
Okay.
We're about 20 minutes through, so yeah, it might be good to
I will plow on. And we can pick up any other questions later on.
Absolutely.
Great. So just to go through some of the basics now. When we're talking about ventilation in this context, we're talking about planned exchange of air with the external environment and the living spaces in your home. And the idea of this is so that you provide fresh air, remove pollutants, moderate temperatures in the summer, especially. That's all a factor. There are two basic different types of ventilation. If you get into, I think I did another webinar a while back for CAFs on the building regs. Part F of the building regs covers all of this in a bit more detail if you want to get into that. But two basic types of ventilation to understand. One is purge, and the other is background or trickle. Purge ventilation is what you want to do when you've burnt the toast. So you want to be able to open the window, get rid of things very quickly. Or when you've had a shower and you've steamed up the bathroom, you want to get rid of that air in the bathroom quite quickly. And you either do that by having a boost on a fan or by opening a window generally. The other type is background or trickle ventilation. And this is the almost, well, ideally, continuous ventilation of some form that you need just to keep topping up the quality of air in your home. So getting rid of excess moisture, getting rid of other pollutants, but just continuously over time. So that's generally at a lower level, less dramatic changes, less dramatic in its air change. There are two basic methods, I guess. Natural, and natural is a bit of a funny word, but basically things that don't need fans, and mechanical extract. And mechanical, so this is usually in some form, there is a fan running somewhere that is drawing air out of your home, or in some cases, pushing air into your home. But across those four kind of different variables, there's lots of different ways that they're being combined into actual systems. I think it's very important not to confuse ventilation, which we want, with infiltration, otherwise known as drafts, which we probably don't want. So that's unplanned air movement through cracks and gaps in the building fabric. So the image there is of a loft hatch where it's a lovely new loft hatch that's reasonably well insulated, but it's not been installed terribly well. So it's just got drafts all around the edge of it, which ideally you don't want. That's partly because it's increasing your energy losses from your home, but also because it's taking air from your home that's warm and wet, usually, compared to outside, and letting it into gaps and cracks in the building where there might be vulnerable timbers or other materials that you really don't want to have water condensing on anywhere. And that is one of the causes of damp that you sometimes get, especially in roof spaces, for example. If you've got condensation in your attic, that's often because warm, wet air has escaped from your house into the loft space, which is cooler, and then it's condensed because it's got nowhere to go. The other thing, people talk about drafty homes and that being part of the ventilation system, which I guess it kind of is, but all of the evidence suggests, and there's some really good articles on this by Kate de Selencourt, that were written for Passive House Plus magazine a while back now. But even in very drafty houses, just because you've got drafts doesn't mean that you've got good indoor air quality, because it's too random and unreliable to ensure that you're getting rid of that moisture and pollutants that you want to. The other thing to not confuse it with is construction ventilation. So this is ventilation that's usually happening outside of the thermal envelope of your home. So the example shown here is below a floor. So the floor is insulated. Hopefully you've got an air tightness layer somewhere in that floor. But you want the space underneath the floor to be ventilated to get rid of the moisture. What we're mainly talking about here today is ventilation that's conditioning the living spaces of your home. Construction ventilation is equally important, but a whole other subject matter. Ventilation is important for your personal health, but I guess the other thing to say is that proper ventilation helps protect the building fabric. When you do get places with higher levels of moisture, if that also combines often with other circumstances, like you've got a thermal bridge somewhere, so a colder spot on the external surface of the building, which sometimes is unavoidable, you end up with water vapor condensing on those surfaces or within the wall or floor or roof, and then that's when your building starts to be damaged. So you need to really get rid of that moisture, and the best way to do that is through ventilation. You might also want to moderate overheating, which is kind of the other problem you get in the middle of summer. So, and which even happens in Cumbria these days. You need to get rid of warm air, often by night ventilation. Though it isn't enough often on its own, you need to combine it with not having probably a wall of glass and a proper shading strategy. As I said before, thinking about the whole house as a system is important. So retrofit, if you're considering doing retrofit works on your home, that's going to change the existing dynamics of heat, ventilation, and moisture movement. You need to think about ventilation while you're doing that. Colin King, who was at the Building Research Establishment and did a lot of studies on failed retrofits over the last decade or more, he said any project that does not consider ventilation is a condensation project. So this is why we're talking about this here tonight. I know it feels a bit counterintuitive though. You're kind of doing a lot of retrofit work to keep heat in your home, and then you're sticking often in somewhere a hole in the wall or in the roof and drawing air out through it that you're losing heat with. And that can seem to countermand the need for energy efficiency. It means heat losses. However, I think it's important to understand that it is entirely justified when you look at sustainability in the round. So we're not just in the business of saving energy, although that is very important. We should also be concerned about making homes that are healthy and comfortable, and where the building fabric is protected so that they exist in the long term. So it's about achieving the right balance, certainly, but again, it's going back to that thinking of the whole house as a system. And we talk about this as seal tight and ventilate right is the kind of mantra for this. So sealing gaps and cracks, so you're reducing heat loss from unintended drafts, infiltration, and then you ventilate to ensure good air quality. I'll go very quickly through these because I think there is, if you're interested in this, there is another webinar that there's a recording of that probably covers them better, especially in relation to the building regulations. But just to very quickly, I think it's worth being aware of, and all of these you can do more research on. There's lots of published information. There's the building regulations. There are then also voluntary standards like Passive House or the ACB building standard, and their carbon light retrofit standards, and also regulations around fuel burning appliances. So in the building regulations, in existing buildings, the key requirement, the baseline, is to not make matters worse. In a retrofit, you're going to be making bigger changes, so you must consider ventilation, and you must now, in part F, it's now explicit that once you've done a certain amount of retrofit work or energy efficiency work, then you must look at upgrading the ventilation system. So these are some of the things that are relevant to that. So part F, part J, and part C. leave you to go and have a look at those links yourselves. Yeah, sorry, I haven't updated this, but the new Part F came into force last summer. It's a much better standard than it was. It's actually quite readable, which isn't common for building regulations. So I would recommend, if you're planning serious works, to go and have a look at it yourselves. And it does consider the depth of retrofit. Excuse me. I'll leave you to have a look at that slide, but this is what Passive House says about ventilation. It's a fundamental part of the Passive House standard, so it's not just about insulation and airtightness. Ventilation is a key requirement if you're going to go for certification on a Passive House or NFIT type project. There are the AECB standards as well, which follow similar principles and are concerned about similar things, but have a slightly more relaxed approach when it comes to the energy targets that you might need. The AECB Carbon Light retrofit training covers this in a lot of depth as well, covers ventilation for retrofit in quite a lot of depth, and it's really worthwhile if you want to progress to that kind of level of understanding about it. For fuel burning appliances, the one to be really aware of is Part J, the building regulations, but there's also HETAS and gas safe. And as I mentioned earlier, the reason this is important is primarily because you don't want to get carbon monoxide poisoning. And that's what all of these regulations are trying to avoid. But there's other good reasons to not have emissions from fuel burning hanging around in your house. When it comes to air tightness and the interplay between air tightness and ventilation systems, so that's when we talk about air tightness, we're talking about how air permeable your home is, or how much you've filled in all the gaps and cracks, or taped around windows, or sealed everywhere. Generally, the more airtight the house, the more there will be a need for continuous and probably mechanically assisted ventilation. But I would just like to reiterate that just because you have a leaky house, it doesn't mean that the air quality will be good. And I would recommend getting some form of planned continuous ventilation anywhere. There's some rules of thumb around how we're airtight, or the air permeability rating of a home for different types of ventilation. But there are other things that come into play in that. So it's not just, again, it's not just about energy efficiency. It might be that you're looking at a particular ventilation system because you've got a noise problem. You're under the flight path to Manchester Airport, so you want to be able to ventilate without opening your windows. That kind of thing can inform your decision making as well. I think this is a variation on the seal tight and ventilate right thing, but one of the reasons why that's important is because it's much easier to design and operate a good ventilation system when you know roughly where the air's going and it's controlled. If you've got uncontrolled and unpredictable airflow, then your ventilation system is probably going to be less efficient and less effective at doing what you need it to. So, in the last, 10 minutes? Have I got 10 minutes? 5 minutes? 10? I'm going to go through some different types of ventilation systems, just to give you an overview. What I would say is that whilst the regulations, things like Part F, set things out in quite a rigid manner and suggest that there might only be 2 or 3 systems, or 3 or 4 systems, depending on how you look at it. There's actually lots of homes, existing homes especially, where there are either systems that have been adapted over time, so kind of a hybrid of some kind. But there are also systems that aren't mentioned in the building regulations, some of them potentially for good reason. And there's lots of, again, in this, there's lots of different variables. So it's whether you have a mechanical or a passive system, whether you're looking to ventilate a whole house as a system, or if you're just looking at single room units. And then you have systems that are extract only. So they're just kind of, they're fan unit, the mechanical part of it, is just pulling air out of your house. Or there are systems that are supply and extract, so it's pulling air out, but it's also pushing air in to replace that air that's gone out, using the fan. Often that will happen in different ways. So the way that people ventilated their homes for hundreds of years, before we had fan systems and before we necessarily understood how things work, although passive ventilation systems have existed for thousands of years, you'd probably term natural ventilation, but I would call it probably more likely unplanned. This isn't mentioned in the building regs because it's not really a system, but it basically just relies on you opening your windows. So that has all of the problems inherent in that. It's very simple, but how successful that is will be very dependent on how hard the wind is blowing that day, whether you remember to open the window or not, whether you can open the window if there are security issues. So there's no guarantees with this, and it's not a system. Well, it's not a system. So we wouldn't recommend this really for any kind of project. The one that's probably most common, though is becoming slightly less common now, is intermittent extract. This is where, for most of the time, your house is just ventilated, again, by window opening, and then there are small trickle vents in windows or walls that are kind of giving you the background ventilation, which is a little bit unreliable, because, again, you're dependent on the weather, how hard the wind is blowing and what the pressure difference is between inside and outside, and that's your house. And then for those times when you're having a shower or when you're cooking, you have an extract fan that you just switch on for that period of time. So again, this is simple, cheap, relatively simple to maintain, although because it's only intermittent, it means that the fans have to run at a higher rate, and can get quite noisy, and then people switch them off, or people forget to just switch them back on again. They use the isolator switches if they're on a humidity stat. So a lot of the studies, evidence from monitoring homes suggests that this isn't really good enough to ensure good air quality generally, but probably especially in more airtight homes. It is, again, a little bit unreliable. Passive stack is no longer in the building regulations. This was the idea that instead of having fans, you would have long duct runs that would go up to your roof. It was quite popular, especially in social housing for a while. It's fallen out of favour, largely again because it is dependent on whether the wind's blowing across your roof that day or not. It also struggled to deal sometimes with more densely populated homes because it's just doing its thing. There isn't, unless you start putting a fan in the system, there's not really an effective way of boosting it. So yeah, it's again a little bit unreliable. But for some people, in some circumstances, if you live in a relatively exposed area, if your home isn't very densely populated, inhabited, then it can work quite well. And it means that there's very little maintenance involved. It's just that to understand how well it will work, you rely on complex fluid dynamics. This system, positive input ventilation, is often put in social housing, and I kind of wish it wasn't. This is where air is continually pumped into the house, usually from a fan located in the loft. So you'll see this, one of these units, often the inlet vent for it is in the ceiling near a loft hatch. It can be quite costly to run sometimes because there have been issues with comfort. They put a little preheat unit into it so that the air coming into your home is a bit warmer. The theory is that because your loft is not outside, the air will be tempered a little bit, so it should be a bit more comfortable. But for one, that shouldn't really be true if your loft is decently insulated. And also you're not sure, I don't know what else might be hanging out in your loft, depending on how well it's maintained. So the other big risk with it, I would argue is that it can force warm, wet air into the building fabric, so increasing the risk of interstitial condensation because you're slightly pressurizing rather than depressurizing the house. Centralized mechanical extract. So in the old building regs, this was referred to as System 3. It's now just a continuous extract ventilation. This is a bit similar to PIV in one respect, in that you've got a central fan unit, but actually what that's doing is extracting air from your wet rooms. And then you would have small inlet vents in windows or walls that are allowing fresh air in to replace that air that you've extracted. Having it centralized can help limit the number of holes you have to put into your building fabric. It also means that the fan unit can be in a place where it's not going to disturb people with noise. So, you know, it can be in a cupboard or in a ceiling void somewhere, so it can be sound insulated, which means it's less likely someone will switch it off. But it is a bit more complicated to install because it requires ductwork and you need space for the ducts to run. It can work quite well in a house where the bathroom and the kitchen are stacked above each other. But as soon as the plans get more complicated, then it becomes more complicated to install. It's a little bit more expensive as well. This is essentially the same system in that it's mechanical extract, but instead of it being one central fan unit, it's individual fan units in bathrooms, kitchens, wet rooms. Again, they run continuously. They'll usually have a boost of some form triggered by a humidistat, so a humidity sensor. But they can also be manually controlled. And this is true of all systems. The boosts can be manually controlled, or they can be linked to a light switch or a presence sensor. This is quite popular, I think, because it's relative. If you've already got intermittent extract ventilation, all it requires is you to swap an intermittent extract fan for a decentralized continuous extract fan and make sure that you've got the right inlet vents to support that. The problem with it can be that if the fans are undersized, they have to work a bit harder, so they can be a bit noisier. So the key is making sure that the fans are big enough for the amount of air that you want to pull through them. And then, yeah, finally, or almost finally, I think, mechanical ventilation with heat recovery. So this is a bit similar to mechanical extract ventilation in that there's usually a central fan unit that's pulling air out of the building. The difference is that they also push air into the building. So they're extracting from bathrooms and kitchens and supplying air to bedrooms, living rooms, other living spaces. What that gives you the opportunity to do is take some of the warmth from that air that's being extracted, pass that air over a heat exchanger next to the air that's coming into the building, so that the air leaving the building helps pre-warm the air coming into the building. It's great for comfort. There are filters on the system, so it's great for helping to catch things like pollen, and if you live by a busy road, it might catch some of the pollutants that would normally come into your house from that. It works really well in very airtight homes. It works less well in less airtight homes, though arguably that's true of most ventilation systems. It costs a little bit more to run just because it's a bigger fan unit. The main complication in retrofit, and the main thing that adds to the expense of it in retrofit, is the fact that you have to find somewhere to run all those ducts. So you're running ducts from the fan unit to every room in your home that's either supplying or extracting. And the units themselves can be quite costly, although that does vary quite a lot. Yeah, that's that one. There is a version of this that's MVHR, but it's single room. So that's a fan unit that has a small heat exchanger in it. that's both pushing air into your home and then pulling it out. Usually it flips between the two. Sometimes there are some units where it tries to do that in one space. Tends to be less efficient than the centralized unit in terms of heat recovery because the heat exchanger is smaller. So that's just physics. There are limits to physics in that. It's simpler to install. I think the question I have about it is whether you end up over ventilating a home because you've got supply and extract in every room in the house, whereas a lot of the other systems are reliant on supplying to some rooms, extracting from others, and the air change rate from that being continuous at a certain level. To ventilate well enough to get rid of pollutants with this, you might have to have a slightly higher ventilation rate. And it can, it's interesting how you balance it across the whole house. But you're probably better off talking to a services engineer rather than me about the intricacies of that. So, very finally, thank you for listening for now. Some simple things you could do now, having talked through all of that, to improve the air quality and the ventilation in your home. First and foremost, if you don't already have one, get a carbon monoxide monitor or even better, an alarm. I'd say get a simple hygrometer, so that's the image there. It's just measuring temperature and humidity. They cost about 10 quid from various hardware stores. It can help you understand kind of what the issues are in your home. Move it around your home. See if there's different issues in different parts of the house. If you have trickle vents, so if you have a system that has extract vent in some rooms, and you've got little slots in your windows or units in your walls that to date you have closed up, please open them because they're part of the ventilation system, and doing so will help improve your indoor air quality. If you have manual switches for kitchen and bathroom extracts, make sure they're on when they need to be. When you're cooking, please use your extract hood. It really does help. Very basic, but please clean fans. Dust and dirt makes them run less efficiently. Think about where you dry your clothes and how that might be better ventilated, whether you can dry your clothes outside, which I know is a struggle in a lot of Cumbria. But if you've got an airing cupboard, or if you can put them in a space that can be well ventilated and hopefully a little bit of heat into that as well. Use low VOC paints and put lids on pans when cooking. And I'll finish there at 8 o'clock.
Thank you very much, Marianne. That was a great sort of range of things covered there, from the really simple, straightforward things to the sort of cutting edge of ventilation technology. Now, I hope that people are going to have some questions for us. So please do, if you can go into the Q&A, put them in there. If you can't find the Q&A, don't worry, just pop them in the chat. As I see, some of you have been using the chat previously. So just do take a moment to have a question. And in fact, I've got a question to start us off. I think you touched on it briefly, but something that people quite often ask me is, well, I've got a dehumidifier.
Mm-hmm.
That'll sort out the moisture. Why do I need anything else? So let's start with that one.
Okay. So the first reason would be the things that we discussed, in that moisture isn't the only problem. So a dehumidifier is dealing with moisture, but it's not dealing with any of the other pollutants in your home. And some of those are, a lot more significant in some ways than moisture. So that's one reason why ventilation is also needed. The other is to do with the physics of moisture and air, in that if you have a dehumidifier running for a while and you're finding that you're emptying X buckets of water from it, you'll go, oh wow, this has got rid of all of this water from the air. This is brilliant. This is doing a super job. Actually, in most instances, compared to the amount of moisture in the air already, it's barely denting it often. I mean, I think there are some instances where a dehumidifier really helps. If you've experienced, I've just had recently, if you've just had a lot of plastering done and you're trying to dry out your plaster and you're desperate to get rid of a bit of moisture, they can support that a bit, but they're helping take the edges off. They're not a solution on their own. Ventilation is a much more effective way of dealing with moisture, simply because of the amount of water that air can hold.
Okay, great, thank you. Well, now we've got the questions coming in. That's great. So I can see 2 in the Q&A, 1 in the chat. I'll start with the one in the chat. How should airing cupboards be ventilated?
Interesting. So, I mean, ideally, if you've got I think one of the reasons why a lot of airing cupboards would have those like wooden slats on them, if they're in a bathroom, would be so that air could get out of them and then hopefully out of your bathroom extractor fan. So that, if you've got enough heat in your airing cupboard from a hot water tank or whatever as well, that should help. Actually, so that was kind of the way it was done. Often now people are fitting dedicated clothes drying cupboards, so they're a little bit more sophisticated than an airing cupboard, but it's and sometimes as part of the wider mechanical extract system, whether that's MVHR or just extract, and they'll actually have an extract point in the clothes drying cupboard, so you're extracting air directly from it, so it's not getting into the rest of the house, which I think is probably the best way of doing it, though not possible all the time, depending on what your layout is and how other things work. But if you make sure that it's not, there is some way for the air in your airing cupboard to get out.
Yeah. I mean, if you've got the luxury of putting in a dedicated ventilation system, such as MEV, extract ventilation, or heat, or MVHR, then you would put a little extract thing into your drying cupboard, and away you go. I've got more questions coming in.
It works quite well because the extract unit or the fan unit is quite often somewhere near the bathroom, so it's just a case of putting in a very short run of ductwork to your airing cupboard.
Yeah. Perfect. Yeah, I've got more questions coming in now. So this one, any comments on cascade ventilation?
So by cascade ventilation, this is something that I've come across more in commercial settings than in homes, where it's ventilation through a series of rooms. I'm assuming that's what's been talked about. It's not my specialist area, so I probably wouldn't want to say too much about it. What I would say is that in a very small, limited sense, when we're doing whole house ventilation, that is a little bit what we're doing. So we're supplying air usually to living spaces, and then relying on the fact that there's air path from a living space, like a living room, dining room, bedroom, whatever, to one of the wet rooms, so bathroom, kitchen, and being able to extract from there rather than individually ventilating each room. But yeah, I probably wouldn't say much more than that because commercial ventilation isn't really my area.
That's fine. That's fine. And a question on MVHR here. With MVHR, if you open a window, does that negate what the MVHR is doing?
So kind of, but how much does it matter? If you are doing that in the middle of summer, then the MVHR probably isn't running in heat recovery mode anyway, and you probably want a bit more air movement, so that's absolutely fine. Who's bothered? It is in the middle of summer. There are instances where you might want to not do that because of noise, but that's a different factor if you live by a busy road or whatever. In the middle of winter, it will reduce the efficiency of heat recovery in the MVHR unit, but there might be a reason why you want to open the window for a bit. I mean, most people, when they've got MVHR systems, don't open the windows much in the middle of winter anyway, because that's the point of having the MVHR. But if you do burn the toast and you want to get rid of the smell really quickly, then opening the window for a few minutes isn't going to dramatically alter things.
Yeah.
So yeah,
Yeah. I mean, the thing I would say is I had MVHR in my previous house as well as this one, and did notice that in very hot summer conditions, we had the heat recovery work the other way around. So actually,
Yes, that's
it
true.
was so hot, didn't want to open the windows, wanted to keep the heat outside. And the ventilation system was actually pre-cooling the incoming air, which was very pleasant. And in the winter, on Christmas Day, we've got lots of people in the house and it was a passive house retrofit, you might throw open the windows just to get rid of a bit of excess heat. But that would be because you'd got 12 people in a house that normally had 4 people in it, perhaps. So unusual circumstances, but the windows are still there. You can still open them.
Yeah, and its impact is quite negligible.
Yeah. So next question, and we've got a couple more come in. So here, James is asking, currently we have no mechanical ventilation in the kitchen. Would you put an extract fan in, probably mechanical extract fan, as soon as possible, even if you're thinking about doing MVHR, or some other system that might be installed at a later date? So it's an interim. Yeah.
Assuming that you're not having any obvious problems with moisture and condensation, so that's not driving the decision. In a kitchen, and depending on exactly how, I mean, if it's in 3 months you're planning on fitting the MVHR, then maybe not. But if it's something you're considering and it might not happen for 3 or 4 years, then I'd say yes, I probably would put something in the kitchen. And that's because a kitchen, I don't know if people, and especially actually if I've got a gas hob, I don't know if people have seen some of the papers or the data on this, but cooking is sadly one of the worst things you can do for the internal air quality in your home, depending on what you're cooking. If you've got a gas hob, you've got all of the things that come from burning gas. If you're sadly, frying halloumi is apparently one of the worst things you can do. So if you're frying halloumi, it's putting all kinds of particulates into the air that just really aren't that great for you. So having some kind of planned ventilation system, even if it's a temporary thing and you just put a hole in the wall to put a fan through for 3 or 4 years, I would say it's worth doing for the sake of your health. Yeah.
I suppose the other thing to mention about kitchens and where you have MVHR, that there's usually a filter on the little extract out of the kitchen itself, but you also need a recirculating cooker hood, which has a good filter on it as well. So you're trying to filter everything twice, once via the cooker hood, but that air, when it comes out of the cooker hood area, will then be extracted out of your kitchen through into the MVHR. And that also needs a filter, because that also will get grubby. I know, because I keep having to wash mine or replace it. And so, that is, there is a lot of stuff that goes into the air when cooking. Yeah,
I think I have seen arguments for, and it was something I debated a lot about in doing my own retrofit, where I've fitted a centralized mechanical extract ventilation in this house. And I was asking a few people whether alongside that, because of what cooking does, whether you'd have the extract that was the whole house system, whether it was worth having the cooker hood also extracting directly to outside, just to get rid of things as quickly as possible. In the end, I came to the conclusion that we wouldn't, which was partly to do with the complexities of balancing those two systems, which I think gets even more difficult in MVHR, because I have seen people argue that you should have an extract hood over your cooker, so going direct to the outside, even if you've got an MVHR system, which is possible to do, but it has to be quite a fancy extract with flaps and balancing so that it's not bypassing your MVHR system.
Sounds complicated.
Yeah, complicated and a little bit expensive. But yeah, I mean, just good if you are frying halloumi, for example, opening the window for a bit, it's also not a bad idea.
So another question here on MVHR: would it be useful to have an MVHR unit which extracts from a bedroom where we dry laundry and inputs air into our bedroom which is difficult to ventilate?
So you would hope any MVHR system would be inputting air into your bedroom anyway, so it would be supplying air to your bedroom. If your bedroom where you dry laundry is actually your laundry, then there might be an argument for putting an extract in there. I suppose the thing to consider is whether, and especially if it's a box room that you're using as a drying clothes space, it's basically a big airing cupboard. The thing to consider would be whether that's quite particular to how you're likely to live in the house. And if you then, your lifestyle changes and you're using that bedroom as a bedroom in the future, or you sell the house and somebody else is using that bedroom as a bedroom in the future, then that, I suppose, how difficult would it be to reverse? You'd have to almost future-proof it so that you could do that, but then reverse it, which would be about thinking about where the ductwork would go. But yeah, I mean, if you've got a room that is difficult to ventilate, having any form of planned ventilation system should help ventilate it if it's properly designed and installed and sized correctly.
And I suppose if you're putting MVHR in, you're probably doing some other things anyway. So you might actually be able to designate a smaller cupboard or a smaller space as your extract. I mean, our previous house of mine had a very small little cupboard in the bathroom. Well, you know, it was quite a decent sized cupboard for a bathroom, but it was small compared to a room. And there was an extract from the MVHR in there as well as from the bathroom. So actually things dried really well. You just put them in the cupboard. It had louvered doors, so it could bring the air in and extract it out of the cupboard. Things dried really quickly. You could bung them up there, shut the door, house looked tidy, job done, and it didn't impact any of the bedrooms. So, you know, if you're putting MVHR in, you might have the opportunity to rearrange things slightly. You know, so that's the other thing to think about is, and you don't need huge space to dry clothes if you've got a well thought out designated place.
They're amazing. I don't know if anyone's seen them, but the clothes drying cupboards that you sometimes see on kind of passive house websites and things are very neat. They're just incredibly well organized with lots of racks, so you can dry clothes that, because it's got a dedicated extract and it's in a warm space, you can dry clothes effectively, even though they might be more tightly packed together than they would be on a washing line outside. So
yeah, it's the future. I haven't quite got there, but it's a nice idea.
Yeah, well, I think especially, you know, places like trying to dry your clothes outside in somewhere like work at, you know, I grew up, I mean, we would do it for large chunks of the year, but it gets difficult when you go out for an hour and it rains suddenly
and everything's wet. Yeah. Right. Well, we haven't got any more questions. Oh, we've got one more coming, so that's good. Yes, someone has asked, you haven't mentioned dual fan heat recovery systems working in tandem.
I haven't, no. I mean, that's getting into a degree of by dual fan, just to check, we're not talking about decentralized mechanical ventilation. We're talking about MVHR unit that has a couple of fans in it. I'm not entirely.
I don't know, Tony, if you can type something else in to tell us what you're thinking about. I mean, there are these. We've got two fans at either end of the building that are connected to each other, so they can one extracts and one puts through, and then they turn around the other way.
Linked systems, yes. So that's effectively a form of decentralized MVHR. I think I have looked at those systems. I find them quite interesting. I suppose I have questions about how effectively they can be controlled and if basically my fundamental question is, if it stopped controlling like that, would you notice? How do you know if it's no longer, those fans are no longer talking to each other?
If they're not in sync, I suppose.
And they're not in sync. Which I'm sure there are ways of doing it, and I know I think that's one of the systems that Cartel have, but it's not something I have direct experience of right now, but I have looked at them. So yeah, and the main reason I didn't mention them is because they're a kind of, this is what I mean about there being many types of ventilation systems, even though the old version of the building regs said there were 4. It's a subset of a decentralized mechanical ventilation heat recovery system. So just didn't have the time to get into that in 40 minutes.
Okay, so we've got some more now. How do you keep ducting clean or clear? Can fluff be a problem, and can it attract insects or pests?
So the insects or pests thing is normally dealt with through having insect mesh at appropriate locations, so they can't get into the ducts in the first place. It is possible to clean ducts, dust them effectively with same way as they would sweep chimneys. So you just take the cover off the end of the unit and poke something up that looks a bit like a chimney sweep. But my experience of it is that it's more of the dust and the muck. And because a lot of the units themselves, so the points at which you're extracting from a room or supplying to a room, but more commonly this would be an issue with extracting, they have filters on them often, like a mesh or some form of filter across them. And then in MVHR or some of the forms of centralized mechanical ventilation, there are filters in the fan unit itself. They catch a lot of the muck, and a lot of the time it's just keeping things clean is just about cleaning the vent cover, because that's where most of the muck goes. And then you might have to clean the ducts out once in a blue moon. But you've lived with MVHR, Tina.
Yeah, I was going to say, I'm actually going to get my a little like service. It's not really an annual service because it's been more than a few years, but it's going to have a little service. So that's next month. So I shall be very interested to see just how dirty it is, how much dirt comes out of my system. Bearing in mind I've had building work done as well, so I've tried to keep it clean, but that's quite difficult even when you've got a bit of DIY going on. So yeah, I shall be the expert shortly on how grubby does it get. I mean, I change my filters regularly for the incoming air and of course for the outgoing air. So there is some dust on that. And the filters do stop the insects getting in because I can see them on my filter. So yes, but I think they do need some level of cleaning or servicing. You can either do it yourself or you can get somebody else to do it if you know what's needed. And I think just that, I've got metal ducts, round ducts with no lumpy bumpy bits in. They're very smooth curved corners, so hopefully they will be fairly clean, but again I shall see. So yeah, we'll watch this space really.
I am just picking up on, so Tony's put a comment saying that MVHR needs air tightness, which Tony, I would agree, it needs air tightness. The house to be quite airtight in order for the system to work efficiently in terms of heat recovery. And if you look back at the slides, there are some rules of thumb recommendations about that. I mean, generally, an air permeability rating of 1.5 or below is when MVHR works happiest in that respect. But knowing some people who live next to motorways or under the flight path from Manchester Airport, there are other reasons for fitting MVHR, even if you do it in advance of some of the air tightness works. So in those cases, they accepted that there would be a bit of an energy penalty. So the system wouldn't be as efficient in heat recovery as they would like. But they really wanted to be able to have decent indoor air quality without having to open their windows next to an urban motorway. So the MVHR is really interesting because it definitely isn't just something that you do because of energy efficiency. I think it's also about comfort, and comfort covering the gamut of noise and indoor air quality as well.
And I think the other thing is with a step-by-step retrofit, which is what I'm doing very gradually at my home at the moment, the MVHR went in quite early because that was that's just the way it fitted in. and I've noticed the relative humidity, which was way too high when I first moved into the house, is actually now in a much better place. My house isn't perfectly airtight. I've put duct tape over a few nasty bits just as a temporary measure before I sort them out properly. But it is bringing the relative humidity down. I can tell which rooms are stuffy and which rooms aren't, because there's some rooms that haven't got air supply into them yet, and they're more stuffy than the other rooms. So it does deliver air quality, even if you haven't got a perfectly airtight house.
Yeah.
I think we've got one more question, and I think we'll wrap up.
Oh.
So Simon's question: can MVHR unit have intake or exhaust through a slate roof if there's no access to the soffits or gable ends due to the nature of the construction?
I believe it can, yes, and I have seen systems like that installed. It's a little trickier, tends to be a little bit more expensive, and obviously there are implications for ensuring a good watertight seal around those, just as there would be with any other penetration through your roof. So I think it's generally not preferred by most MVHR designers, but it is possible.
The other thing to say is that it doesn't have to go in the loft. I mean, mine is in the back of a cupboard. And it goes straight through the wall on the first floor, but straight through a section of wall. I've got the in and the out ducts. So that little cupboard, that doesn't bother anybody. It's in there. It's not loud. It's well designed. It's quite quiet. And, it just gets on with it. So that's a straight through the wall. No need to go into my roof. And actually it's better to keep the MVHR unit in the warm zone, because your heat recovery is going to be better if you're not losing heat to the loft space, for example. So
I would I've ended up with my MAV unit being in above a false ceiling in the bathroom, so it's got its own little loft hatch, but again it's in the warm side of the construction build-up, and it just goes out through a hole in the wall. And that seems to work quite well, and means it's still relatively, I just need to get up on a step ladder and stick my head up through that hatch, and it's accessible for maintenance. So, and kept the duct runs to outside as short as possible, which is the other important thing.
Right.
Right. Yeah.
That's come to the end of our questions. So thank you very much for that, Marianne. I think we've covered quite a lot of meaty questions there. So if anyone thinks of questions later on that they haven't answered, it might be, well, it won't be coming up in the next webinar, but you might find that there's answers in other webinars that we've already run, or on our YouTube, or do phone CAFs. We have 2 advice teams, one for sort of basic energy efficiency and one more for retrofit consultations. So do get in touch with us. Again, the details will be in our follow-up email. So we do offer these free short advice calls as a starting point. So on the YouTube, we've got our this webinar will end up on YouTube, as are the others already that we've done recently and previously. And if you want to keep up to date with future events that we might be running, sign up to our newsletter and look out for the Cumbria Greenville Facebook page, because that's a useful place to talk to people who are dealing with retrofit or involved in some way. So yeah, just to finish off really, if you want to hear more from us, or you want to know when we've got new events coming up, sign up to the CAFs newsletter. We will be holding other webinars, but we've got none planned in right now. There will be others at some point. When I email out the link to this recording so that you can listen, if you want to listen to it again, or for those people who missed it, there will be other links in there for a survey. So do fill in the survey and give us some feedback on the webinars. That will also have the information about CAF's advice generally, and our new shop with our gift cards. Anyone who's donated to CAFs when booking onto the webinars, thank you so much. It does help us, whatever we do, go a bit further. And so finally, I'd just like to say a very big thank you, Marianne, for your talk and for all the questions, taking whatever questions people could come up with. And thank you everyone for attending, for being very attentive, and for coming up with some really interesting questions. And I hope to see you again at another CAFs event soon. Thank you very much.